Hi everyone. In this video we're taking a look at graphing and evaluating piecewise functions. So we're given the rule a of x, and literally you'll see different pieces or parts of three different functions. We have 2x minus 1, which would be a linear function, some type of diagonal. We have the absolute value of x, which is an absolute value graph or a v-shaped graph. And we have 4. 4 is just going to be a horizontal line, as is any number. F of x equal to some number is a horizontal line. So that one won't be too bad to graph. And one of the things I noticed with piecewise functions is people have a difficult time getting started. If I gave these three separate graphs in three separate questions, I should say, it would be a little bit easier. But when they're all kind of jumped or jumbled into one, it gets a little confusing. So what I like to do, or how I explain this, is with you've heard me say this in class, or maybe not, a mini table approach. So I give each function its own little table of values, and then we graph them separately. Rather than thinking of it as one huge thing and you're getting overwhelmed, break it apart and treat it like three separate problems at first. So we're going to start with the top one, which I'm going to use purple for, and I made a little XY table. Now the tricky part is knowing what X values to use. You can't just use anything you want, because if you look on the right, we actually have a specific rule, or I should say domain, for each rule, which is right here. Okay, what those represent, that's saying, all right, this graph only works from here to here. This graph works from here to here. This graph is defined from this point to this point. I'm going to start with -2 in my table, and then put values smaller than -2. Because it says x has to be less than -2. Now, one thing people confuse with that type of rule, they might say, why are you putting -2 in your table? Why not start with -3? Because they're arguing, oh, it can't be equal to -2. So it doesn't make sense to put in your table. And that's correct, but the one thing we're missing, if we put -3 in our table, what about all the decimals in between -3 and -2 that do work? -2.001 technically is defined there. But if we start at -3, we're losing it. So we're going to start at -2. What's the little trade-off? What do we do to represent that it's not included? We just use a open circle. And there's no cap on the other side. We can go all the way to -1 million if we want. So how do we represent that? Just with an arrow in that direction. Now the y values. You could use a table if you your graphing calculator for this part if you want. It's actually pretty simple arithmetic here. We're going to multiply the x value by 2. So this would be -4. And then I'm going to subtract 1 from that, which would be -5. And so forth. So the next one would be -7. And the one after that would be -9. Again, that's just plugging in the x value to the rule. If you want to see that done a little bit more formally, for example, the middle value, this is really what I'm doing either in my head or with a combination of the graphing calculator. Okay, so now I'm going to actually graph this one. Could do all your tables at once. I'm just going to graph. I'm done with one piece, so let's get it out of the way. So the first point, I want to be careful not to actually put a filled in circle, because then we can't really fix it. I'm going to put an open circle at -2, -5, and that's again because of this right here. It wasn't included. Everything except touching right there works. And the following points are going to look like this. Okay, and now I'm going to connect it with a straight line and put an arrow on the end because this does continue on forever in that negative direction. Okay, so we're 1/3 the way there. Our middle function, the absolute value of x, I'm going to do in green. Once again, I'm going to use a mini table. This one's actually going to be a little bit easier because we have one of those sandwich inequalities. So we know exactly where to start and where to stop. Sometimes we can cheat and just use sorry, my iPad's acting crazy here. We can cheat and just use 2 endpoints, but because this is a V-shaped graph, we don't want to do that. If it was linear, we could just use the two endpoints and not really care about the rest. But unfortunately here, I mean, it's not that much more difficult. We do have to use all the values. And now, just like we did earlier, all I'm going to do is plug in to the rule. And this is easy because it's just saying take the absolute value of whatever x is. So this is going to be 2. This is going to be 1, 0, 1, 2, and 3. Okay, the absolute value of whatever x is. And now, if we look at our domain, we knew to go from -2 to 3, but let's check out, are they included, are they open or not? Both of those endpoints are included, so I'm going to put, I like to make little notes next to my table. Just a reminder that, hey, both endpoints should have a filled in circle on them. And I'm going to plot these. So I have -2, 2, -1, 1. I don't have to worry about making an open circle or not. And it makes almost like a check mark. That's my graph. Okay. And our third and final function, let's go with, I don't know, dark blue, is just 4. This is actually the easiest one, but unfortunately it's one that people make the most mistakes with because they get a little confused. There's nothing to plug into. I'm going to go, I don't need much space. Go right here. So I'm going to start at 3, and I'm going to put 2 values above 3, because the rule here is x has to be greater than 3. So just like with the top function we did in purple, I'm putting 3, even though it's not included. I'm just going to represent it with a open circle. Goes on forever in the positive direction, so an arrow on the other side. And now this is the easy part, but like I said earlier, unfortunately, people make a little mistake here. They're not sure what to do. The rule is that y has to be 4, saying the function is equal to 4. That's literally the rule. So what is the y value in each case? Just 4. So I'm going to graph 3, 4 with a open circle. And now I don't even really have to plot because I know this is going to be a horizontal line. Okay? Any function equal to a number, if you want to make note of that somewhere, is always going to be horizontal. Sometimes that gets a little confusing. We're so used to saying the phrase like plug in, and then you can't plug in all of a sudden, and people don't know how to handle that. But that's all it is. So if you take a look, we've completed our graph. We have 3 distinct pieces, 3 function rules. I have my arrows in the right spot. I have open versus closed circles clearly identified. So now we're just going to evaluate it, or read our graph basically. So the first question says, we did graph it. Second question, I should say, says evaluate a of 3. So in other words, when x equals 3, what's the y value of the graph? So we're looking here. This is where x is 3. And if we start to go up here, it looks like we have 2 choices. Those 2 choices would be this or this, which is 3 or 4, as our possible y value answers. So which of those 2 do you think we want? Now, even though it looks like both could be a possible answer, I'm going to select the bottom one. A of 3 is equal to 3. So why the bottom one? Think about the relationship between open and closed circles. Even though that top arrow looked like it was a possible selection, it's not actually a point on our graph. It's saying that it doesn't touch there. It's after that point. So we want the closed or filled in circle there. That's usually a trick they add. They will throw one where, very similarly, let's say we wanted like a of -2. Once again, you'd have 2 choices to make, or seemingly 2 choices to make. Which one would you want here? Once again, you would want this one, and the answer would be 2. Okay, so if it's open versus closed, what's the value you want? The closed, the included value. The open is not included. Okay, and last but not least, find all the values for which a of x equals 1. So this is saying, if you don't like that phrasing, basically, where does y equal 1? Where does the function equal 1? A of x and y are synonymous here. So the function equals 1 in 2 spots. it would be right here and right here. Okay, these are the y values. Think about almost like with your eyes when you're answering this question, like a horizontal line jutting through 1. Where does it hit the graph at any spots, at any points? And it would be at those 2 spots, so I'm just going to make note of the actual values. So that's at -1 and at +1. We have an output of 1. That would be our answer. We could phrase it any way we want. We could say this as well. Okay, so this is evaluating and graphing, more importantly, a piecewise function. It could be very overwhelming at first, but by organizing it, separating it into different mini tables, observing what types of circles under the given domain you should use, it makes things very clear, and all of a sudden it starts to flow and become a little bit easier to understand what exactly it is you're doing. So thank you for watching, and hopefully you found this helpful. Thank you.